What we are about to do is actually doable at home.
Just be sure you have adult supervision.
Hi, I'm Ethan Howie.
Hi, I'm Brandy Gobert. Hi, Sabrina Bowen.
I'm Christian Kavanaugh.
And I'm Regine Gomez.
We
are the Swan Busters! Today we will be testing a common kitchen myth that saves both time and energy. The myth states that there is a correlation between the starting temperature of the water and the time it takes to boil. We predicted the higher the starting temperature is, the faster it will reach its boiling point, which is 100 degrees Celsius. The independent variable is the different temperatures of the water, and the dependent variable is the time it takes to boil.
To test this hypothesis, you will need a cooking pot, a measuring cup, a faucet with adjustable temperature knob, a thermometer, tongs, gas stove, a gas meter, a stopwatch, and oven mitt for safety.
This experiment will occur throughout the course of 5 days. For each day, a different starting temperature will be tested. On the first day, the lowest temperature from the tap water possible, 26 Celsius, will be tested, and it will increase in a period of 5 days until the highest temperature of water from the tap possible, 45 Celsius, is reached.
Okay, so this is trial 1, and the starting temperature is 26 degrees Celsius.
Check the gas meter and record the initial gas use of the household. Turn on the knob of the faucet to the coolest or lowest setting and fill the measuring cup with 2 cups of water. Pour the water to the pot and record the temperature using the thermometer. In this experiment, the coolest setting the faucet can provide is 26 degrees Celsius. Place the pot of water on the stove and turn it on to the highest setting possible. And immediately start the stopwatch to record the time it takes to boil. Using the tongs, submerge the tip of the thermometer in the water and wait for the time. Once it reaches 100 Celsius, stop the stopwatch and turn off the gas stove. Record the time it took for the water to boil. Check the gas meter once again and record the final gas usage.
To quantify gas usage, count how many increments the 2-foot or bigger dial moved from before the experiment to after. Then multiply the answer to 0.2.
Repeat these steps 4 more times with the same temperature and list the results in an X and Y table. Remember to look at the gas meter before and after each trial to see whether or not these methods conserve natural gas.
Okay, this is trial 2.
Trial 2,
Okay,
what?
Trial 2, and the starting temperature is 30 degrees.
30 degrees.
30, okay.
These are the results for the 5 trials for 30 degrees Celsius.
What trial is this?
This is, trial 3. Starting temperature 36 degrees Celsius.
These are the results for the 5 trials for 36 degrees Celsius.
Trial 4.
Okay. Oh, there's an ant in there. Okay, trial 4. Okay. The starting temperature is 40 degrees.
These are the results for the 5 trials for 40 degrees Celsius.
Okay, so this is our last trial, trial number 5, and the temperature of this water is 45 degrees Celsius, which is the highest setting on the tap.
These are the results for the 5 trials for 45 degrees Celsius. This graph shows the average time it took for the different starting temperatures to boil. This graph shows the average gas usage when different starting temperatures were tested.
After testing 5 different temperatures, 5 trials each, we conclude that there is no correlation between the starting temperature of the water and the time it takes to boil. We suspected that the higher the starting temperature, the faster the time to boil will be. However, looking at our graphs and evidence, it shows that the time it takes to boil for each temperature is spontaneous, and there is no clear increasing or decreasing pattern.
The myth was busted! I didn't say it.
Oh, shoot.
The following unexpected and unpredictable mistakes were avoided as much as possible. The inconsistent positioning of the pot on the stove is one of the sources of error. There are times when this pot is right on the center of the grill, and there are times when it is a bit off center. Pouring the water from the cup to the pot, leaving the pot on standby for a few seconds, and slowing down the process for filming purposes all contribute to the sources of error. There is a possibility that the temperature of the water has cooled down a little bit, which might have affected the boiling time. Another possible source of error is the misinterpretation of the thermometer. The magnifying glass casing of the thermometer made it difficult to read at times. The small inscriptions of the thermometer added to the challenge of interpreting the temperature of the water.